Hello, this is Team HTL-Anichstraße number 620. My name is Matteo Reiter, aka Melectron, and in this video we are going to present our crate-based robot called Croissant, specifically its main arm. The main purpose of Croissant's arm is to pick up the yellow cubes, aka logs, or Botball from the server racks, bringing them to their desired location in order to score most effectively and or stack the cubes to multiply points. Before we continue with the in-depth mechanical review, here is a list of all the parts used to build the arm. The list can also be found in the video description. Our most important electronics parts are a camera, a motor and some servos. We didn't use a lot of special Lego parts, mostly just axles, lift arms and some pins. The arm is mostly built from metal channels and plates. We also used a lot of our nuts and bolts on this subassembly. Lastly, we used some IGES chain links to contain the wires. Now let's take a closer look at our concept and implementation of the arm. The robot uses a pulley system driven by a motor in order to control the angle of the elbow joint. Together with some aluminum channels and a threaded rod, it forms sort of a parallelogram mechanism. This preserves the angle of the gripper with respect to the table, even when the shoulder moves. In order to accurately position the elbow, there are limit switches on either end that are used to calibrate the motor positions during a homing sequence. The shoulder joint is actuated using a simple servo drive. All the arm motors are fixed to the robot base, improving the weight distribution and saving on extension cables. Currently, the gripper is mounted on another servo, allowing it to rotate around its mounting point. This might be removed later though, if we don't need it for anything specifically, in order to save on weight and complexity. The gripper itself is driven using a Z mechanism, moving both of its claws in opposite directions. The robot uses its camera to optically track the yellow cube by its color. It will constantly check for alignment with a targeted cube while driving, in order to ensure the cube is centered in the gripper. Once the controller has determined the cube is close enough for pickup, it will close the gripper and gently lift the cube before transporting it to the destination. Even though this gripper looks pretty flimsy, this is actually helpful for grabbing cubes. Due to its springy nature, it can adjust to fit the cube and even pick up cubes at weird angles. Thanks to the rubber tracks, it does a really good job of holding its target in pretty much any orientation. To conclude, our robot is able to successfully track and pick up various game objects, which we have verified through extensive testing. Additionally, we have spent countless hours developing a navigation system, allowing the robots to accurately track their position and navigate to any location on the game table, even without any guidance from cameras, distance sensors or line followers. You can see it in action in the background right now. While some of our systems are still in development and may change, we are very happy with our progress so far and are confidently looking forward to the tournament.